In question 1, we are being given f of x here, a and b are constants. We are told that when f of x is divided by x plus 1, the remainder is 4. This means that f of negative 1 must be 4, and this would allow me to obtain that a plus b is negative 1. So I will substitute the x with negative 1. It's minus 1 to the power of 4 plus a times minus 1 cubed minus 3 times minus 1 squared plus b times minus 1 plus 5. So this is 4 is equal to 1 minus a minus 3 minus b plus 5, which leads to a plus b is negative 1 as required. We are also told that when f of x is divided by x minus 2, the remainder is negative 23, and we need to use this information to find a and b. I will start by saying that f of 2 must be negative 23. The objective is to obtain another equation in a and b and then solve simultaneously. So I'm substituting x with 2 here, and I get this equation here. Let's simplify things. Negative 23 is 16 plus 8a minus 12 plus 2b plus 5, and this leads to negative 32 is equal to 8a plus 2b. It makes sense to divide everything by 2 to get the negative 16 is 4a plus b. Then I've got two simultaneous equations, 1 and 2 here. I can deduct 1 from the other, so 2 minus 1 is giving me that 3a is negative 15, which means that a is negative 5, and then I will substitute the negative 5 into the first one, and I've got that negative 5 plus b is negative 1, which means that b is 4. In question 2, we've got the curve with equation y is x cubed minus x squared minus 16x plus 2, and we need to use calculus, this means differentiation, to find the x coordinates of the stationary points. We know that for differentiation we get the power down and we deduct 1 from the power to get 3x squared minus 2x minus 16. We set it equal to 0. This factorizes into 3x minus 8x plus 2. And therefore, we've got the 2 points, x is 8 over 3, or x is negative 2. And these are the x coordinates of the stationary points. In B, we need to justify by further calculus the nature of the stationary points. This means we need to use the second derivative, so the 2y by the x squared. So we differentiate once more to get 6x minus 2. And what we need to do is evaluate the second derivative at each of the 2 points we have found in A. So at x is 8 over 3, would be 6 times 8 over 3 minus 2, which is 14. This is greater than 0, therefore it's a minimum. And I will repeat the process for x is negative 2. So the second derivative when x is negative 2 is 6 times negative 2 minus 2, which is negative 14. This is less than 0, and therefore I conclude that this is a maximum. If there is one thing I would highlight here, I would be the explicit comparison with 0 to justify the conclusion for a minimum or a maximum. If you do not write the greater or less than 0 and you just write the conclusion, you will be penalized. In question 3, part I, we need to solve 7 to the x plus 2 is 3. We need to give our answer in the form log of a base 7, where a is a rational number. So I will start by writing 7 to the x plus 2 is 3. I could take log of both sides to get the x plus 2 down, and it should be base 7 because I'm aiming for an answer that should be log base 7. This means that the x plus 2 can come down, and then I've got log of 7 base 7 is equal to log 3 base 7. Now log of 7 base 7 is 1, which means that x plus 2 is simply log of 3 base 7. I know that I need to end up with one logarithmic expression, so what I could do is write 2 as log of 49 base 7, because 49 is 7 squared, and this is equal to log of 3 base 7. So x is log of 3 base 7 minus log of 49 base 7, and therefore x is log of 3 over 49 base 7. In II, we're being asked to use the laws of logarithms in order to solve the equation here, and the idea is to get all the logarithms together and express them as a single logarithm. So we've got 1 plus log of y base 2 plus log of y plus 4 base 2 is equal to log of 5 minus y base 2. We know that the sum of the logarithms is the logarithm of the product, so we've got log of y times y plus 4 base 2 is log of 5 minus y base 2, and therefore 1 is log of 5 minus y base 2 minus log of y brackets y plus 4 base 2, and hence 1 is equal to the log base 2 of 5 minus y over y brackets y plus 4. I will now open up the logarithm by writing that 2 to the 1 is 5 minus y over y plus 4. I could cross multiply to get 2y plus 4 is equal to 5 minus y, which leads to 2y squared plus 8y is 5 minus y, and therefore 2y squared plus 9y minus 5 is 0. Now I will factorize this into 2y minus 1 y plus 5, and therefore from this we get two possible solutions for y. The first one is 2y minus 1 is 0, which means that y is a half, and the second one is y plus 5 is 0, which means that y is negative 5. What we need to be careful with is checking the solutions we obtain here, whether they are compatible with the original equation. In the original equation, we had log of y plus 4, 5 minus y. We want all of these always to be greater than 0. Otherwise, we get a math error in the calculator. And it is therefore obvious that the negative 5 will cause an error here. So the y is negative 5 is not a valid solution, so we reject this. It's not valid. In question 4, it's a binomial expansion question. We need to get the first three terms of 2 plus px to the power of 6. So 2 plus px to the power of 6 will be 2 to the 6 plus 6 choose 1, 2 to the power of 5 times px plus 6 choose 2, 2 to the power of 4 px squared plus dot dot dot, and this simplifies to 64 plus 192 px plus 240 p squared x squared plus dot dot dot. Notice the use of brackets here to avoid common mistakes when we raise to higher powers. And then, given that in this expansion the coefficient of x squared is negative 3 over 4, we have to find the possible values of p. So I will actually use what I have found in A and say that 3 minus a half x times 2 plus px to the power of 6 is equal to 3 minus a half x times 64 plus 192 px plus 240p squared x squared plus dot dot dot. We are being given that the coefficient of x squared is negative 3 over 4, and I will have to consider which combinations will give me an x squared term. It's obviously the constant with the x squared term and the x with the x. So this will give me 3 times 240p squared x squared plus negative a half x times 192p x plus dot dot dot. So this is giving me 720p squared x squared minus 96p x squared. So I know that the coefficient of x squared will be 720p squared minus 96p. This will allow me to form an equation. 720p squared minus 96p is minus 3 over 4. I will cross multiply by 4 to get 2880p squared minus 384p is negative 3. I will collect everything on one side. So 2880p squared minus 384p plus 3 is 0. And there is no chance I will attempt in factorizing this. I will use the quadratic formula. So p is minus b plus minus b squared minus 4ac all square root over 2a, 2 times 2880, and this is giving me answers for p being 1 over 8 or p being 1 over 120. I knew I was expecting more than one answer because I was asked to find the possible values of p. In question 5, we need to use algebra to prove that for x being greater than or equal to 0, we've got 3x plus 1 is greater than or equal to 2 root of 3x. Now, this is a proof question. We need to explain everything clearly. Unfortunately, I don't have a starting point here, so I'll actually do some investigation by starting from what I have to show to be the case. So if I was to start from 3x plus 1 greater than or equal to 2 root of 3x, the first obvious thing would be to square everything. So 3x plus 1 squared is greater than or equal to 2 root of 3x squared. So we get 9x squared plus 6x plus 1 is greater than or equal to 4 times 3x. So 9x squared plus 6x plus 1 is greater than or equal to 12x. I will collect everything on the left-hand side to get 9x squared minus 6x plus 1 greater than or equal to 0, which is a perfect square. 3x minus 1 all squared greater than or equal to 0. Now the good thing is that all of this investigation has led to the starting point I didn't know where to find at the beginning. So this is not a solid mathematical proof. I will call this the jottings, and I will construct a formal proof now. So my proof would be that 3x minus 1 all squared is greater than or equal to 0. We know this is true because whenever we square something, it can't be negative. So I will expand. So essentially, I'm playing all the steps in reverse order now, which means that 9x squared plus 6x plus 1 is greater than or equal to 12x. So this is 3x plus 1 squared greater than or equal to 12x. I will now take the square root and get 3x plus 1 greater than or equal to the square root of 12x, since x is greater than or equal to 0. So I know for sure that because x is not negative, when I take the square root of 12x, I'm not taking the square root of a negative number. And therefore, this allows me to conclude that 3x plus 1 is greater than or equal to 2 root of 3x as required. In II, we need to show that the following statement is not true. The sum of 3 consecutive prime numbers is always a multiple of 5. So we need a counter example. This is a particular example for which the given statement is false. With some trial and error, we come up with the example of 5 plus 7 plus 11. These are 3 consecutive primes. This is giving me a result of 23, which is not a multiple of 5. In question 6, we need to show that this equation can be written in this form, a cubic in terms of sine theta. So I will actually start by writing exactly what I have been given. 3 sine theta cos theta over 2 sine theta minus 1 is equal to 5 tan theta. I can write the tan theta as sine theta over cos theta. So this way I will only be dealing with sines and cosines. So this is 5 sine theta over cos theta. And then I will cross multiply to get 3 sine theta cos square theta is equal to 10 sine squared theta minus 5 sine theta. We can write cos squared on the left hand side as 1 minus sine squared. And we see the cubic forming slowly. So I will expand the left hand side to get 3 sine theta minus 3 sine cubed theta is equal to 10 sine squared theta minus 5 sine theta. And then I will move everything on the right hand side to get that 0 is equal to 3 sine cubed theta plus 10 sine squared theta minus 8 sine theta as required. And then we have part B. It says, hence solve this equation here. We're between minus pi over 4 and pi over 4. So we are in radian mode and we need to give answers to 3DPs where appropriate. This really hints at the fact that some of the solutions will be nice numbers and some of them will have to be given to 3 decimal places. So comparing this with the original, we see that theta becomes 2x. And therefore the first thing to do is write this down as 3 sine cubed 2x plus 10 sine squared 2x minus 8 sine 2x is 0. I will factor out the sine 2x, brackets 3 sine squared 2x plus 10 sine 2x minus 8. And then we can further factorize this into sine of 2x, brackets 3 sine 2x minus 2, brackets sine 2x plus 4 is equal to 0. So either sine of 2x is 0 or sine of 2x is 2 over 3 or sine of 2x is negative 4. Obviously this last part is rejected. You can never have the sine attaining a value of negative 4. It's always between minus 1 and 1. So we say reject, not valid. For sine of 2x being 0, we know that the principal value is 0. And this means that 2x is equal to 2 pi k, or 2x is pi plus 2 pi k. If I divide everything by 2, I get that x is pi k, or x is pi over 2 plus pi k. For sine of 2x being 2 over 3, the principal value from the calculator is 0.72973. So 2x is 0.72973 plus 2 pi k, or 2x is pi minus 0.72973 plus 2 pi k. Again, dividing everything by 2 gives me that x is 0.36486 plus pi k, or x is 1.20593 plus pi k. Notice that I've been using more accuracy than the 3 decimal places, and I will keep the 3 dp accuracy for the final answers. We are between negative pi over 4 and pi over 4, and the only solutions that fall within this range are 0 and 0.365. In question 7, we've got this graph of power against the time, and we have this expression for the power. We are told to complete the diagram here, the table. So using the calculator, we get that when t is 10, the power is 1.2, and when it's 11.5 is 2.821. And then we want to use the trapezium rule with all the values in the table to estimate the amount of energy produced. This is going to be the area under the graph, which will be estimated using the trapezium rule. So it's always a half times the height of the trapezia, which is the difference between 2 consecutive values of t, so 0.5 in this case, and then it's the first p value and the last one once plus twice all intermediate values, and then it's a matter of putting everything carefully on the calculator. We need to give an answer to 2 decimal places. This works out to be 4.61 kilowatt hours. Question 8, it's a sequence defined recursively according to this rule here. We need to find an expression for A2. Well, based on what we are given, we know that A2 is 2 times A1 plus 3 all squared minus 7, which will be 2 times P minus 3 plus 3 squared minus 7, which is 2p squared minus 7. And then we are told that given that the sum of an from n equals 1 up to 3 is p plus 15, find possible values for A2. So we have that the summation of the first 3 terms, so A1 plus A2 plus A3 is equal to p plus 15. And the first thing to do is find an expression for A3. A3 is twice A2 plus 3 squared minus 7. I'm going to be using the answer from A, so it's 2 times P, 2p squared minus 7 plus 3 all squared minus 7. This is 2 times 2p squared minus 4 all squared minus 7, which gives me 2 times 4p to the power of 4 minus 16p squared plus 16 close brackets minus 7. So this is 8p to the power of 4 minus 32p squared plus 32 minus 7, which simplifies out to 8p to the power of 4 minus 32p squared plus 25. So let's substitute the values for A1, A2, and A3. We have p minus 3 plus 2p squared minus 7 plus 8p to the power of 4 minus 32p squared plus 25 is equal to p plus 15. All of this simplifies to 8p to the power of 4 minus 30p squared is 0. I will factor out the 2p squared and in brackets 4p squared minus 15, which means that either p is 0 or p squared is 15 over 4. I have not been asked to find the value of p, I've been asked to find possible values of A2. We know that A2 is 2p squared minus 7. So in this case, if p is 0, then A2 is 2 times 0 squared minus 7, which is negative 7, or it's 2 times the 15 over 4 minus 7, which gives an answer of 1/2. These are the two possible values for A2. In question 9, we've got a circle with the equation shown here, and we need to write down in terms of k the coordinates of the center and the radius. The prompt to write down means that the answer is obvious, it's in front of us. We know that the center has to be k, 2k, and the radius has to be the root of k plus 7. So in AI, I will simply say k, 2k, and for II, we've got k plus 7 root, that's the radius. And then we have that the point 2, 3 lies on the circle, so it satisfies the equation of the circle, and we need to show that 5k squared minus 17k plus 6 is 0. So I will start by substituting x is 2 and y is 3 into the given equation to give me 2 minus k squared plus 3 minus 2k squared is equal to k plus 7. So 4 minus 4k plus k squared plus 9 minus 12k plus 4k squared is equal to k plus 7. And I will collect everything on the left hand side to get 5k squared minus 17k plus 6 is 0, which is exactly what I had to show. In II, we need to find the possible values of k, so I can factorize the given quadratic in k into 5k minus 2 brackets k minus 3, which means that the two possible values for k are k is 2 over 5 or k is 3. And then the last part for 5 marks, so quite some work involved here. We are told that the tangent to the circle at P intersects the x-axis at point capital T. Given that k is less than 2, calculate the exact area of triangle OPT. So I will start by drawing a sketch to show all the given information. My starting point will certainly be that since k is less than 2, this means I need to pick the value of 2 over 5. So this is the diagram here. We've got the circle. It's centered at 2 over 5, 4 over 5. We've got somewhere the point P with coordinates 2, 3. And we draw the tangent, and the tangent cuts the x-axis at point capital T. I will start by finding the equation of the tangent here because I need to find the coordinates of T. What I'm after at the very end of the day is the area of the triangle I've highlighted here in yellow. So the gradient of CP is y2 minus y1 over x2 minus x1, which gives an answer of 11 over 8. We know that the right angle here means I could deduce that the gradient of the tangent is just the reciprocal of what I just found with the sign change, so it's minus 8 over 11, and therefore the equation of the tangent would be y minus y1 is mx minus x1. We know that at point capital T, y is 0, so minus 3 is minus 8 over 11 brackets x minus 2, which means I could cross multiply to get negative 33 is negative 8x plus 16, and so 8x is 49, which means that the x coordinate of point T is 49 over 8. It makes sense to update my diagram here and add this information. So the area of the triangle here will simply be the base, which is 49 over 8, times the height, which is simply the y value of point P. This is 3 here. So I will simply say that the area is 49 over 8. We said this is the base times the height of 3, all of it over 2, base times height over 2, and this is 147 over 16 squared units. In question 10, we've got a question on sequences. We've got Owen, who's training for 12 weeks. He's following this scheme where on Sunday in week 1, he runs 15 kilometers, and on the last Sunday in week 12, he will be running 37 kilometers. So under plan A, he keeps increasing the distance he's running each Sunday by the same amount, and we need to calculate the distance he will run on Sunday in week 5. So I like to draw up a table here. We know that in week 1, he will be covering 15 kilometers. In week 2, it's gonna be 15 plus a fixed amount D. In 3, it's gonna be 15 plus 2D, and it's obvious that in week 12, this will be 15 plus 11D, which we have been told to be equal to 37. So 11D is 22, which means that D is 2. So if we follow this pattern on week 5, this will be 15 plus 4D. So it's 15 plus 4 times 2, which is equal to 23. And then in part B, we've got a different training plan whereby we keep increasing the distance by the same percentage. So this is a geometric sequence now. So I will follow a kind of a similar approach. Again, in week 1, we have that they've covered the distance of 15 kilometers. Week 2, it's 15R. Week 3 is 15R squared. And therefore, in week 12, it's gonna be 15R to the power of 11. This is equal to 37. So R to the 11 is 37 over 15, which means that R is the 11th root of 37 over 15. And this will allow me to find the distance covered in week 5. So in week 5, it's gonna be 15R to the power of 4, which is 15 times the 11th root of 37 over 15 raised to the power of 4. And this is giving me 20.8 kilometers. So in C, we're told that Owen will also run a fixed distance of X kilometer each Wednesday over the 12-week period. We have been told that X is an integer, and the total distance he will be running on Sundays and Wednesdays will not exceed 360 kilometers. And we need to find the maximum value of X under plan A and then under plan B. So in other words, we know that under plan A, the distances covered on Sundays form an arithmetic sequence, and the total distance covered on Sundays will be S12. And then you've got the 12 Wednesdays that will each contribute X kilometers, so 12X. And all of these should not be more than 360, so less than or equal to 360. The summation formula for arithmetic sequences is n over 2, 2a plus n minus 1d, and we found d to be 2, plus 12x less than or equal to 360. So this leads to 312 plus 12x to be less than or equal to 360. So 12x is less than or equal to 48. So x is less than or equal to 4. And therefore the largest integer value for x is 4. And then in II, we've got that S12 plus 12x is again less than or equal to 360. However, this time S12 is the summation of the first 12 terms of our geometric sequence. So we've got 15 brackets 1 minus the 11th root of 37 over 15 raised to the power of 12 over 1 minus the 11th root of 37 over 15. That's the summation formula for a geometric sequence, plus 12x less than or equal to 360. This gives me that 294.2 plus 12x is less than or equal to 360. And therefore 12x is less than or equal to 65.8. Dividing both sides by 12 gives me x to be less than or equal to 5.48. And therefore we can conclude that the largest integer x is 5.